Hello everyone, I welcome you all to today's session, which is a continuation session from the previous video that we had on the geometry topic. So in today's class we shall be taking up a few more concepts. Alongside the concepts we shall be solving a few questions too. So let's get started. So last class we were discussing triangles. So there are few more details that we have in triangles that we should be aware of, right. So for example, have a look at this particular question. So pause the video at this moment, give this question a try, see what concept, alright, what formula, what property of triangles are we going to use to get to the answer in this particular question. So have a look at it, pause the video, and however will be discussing the question right away, alright. You can just resume the video and see whether your answer matches with our discussion here or not. So let's get started. So the question says, in a triangle PQR, PQ is 19.5, so one of the sides, PR is 14 centimeters, so the other side. PS, the altitude drawn to QR, the third side, QR is the third side, is 6 centimeters. So let me just try to draw the diagram here. So if I take the triangle PQR, so here it says PQ is 19.5, so this side length, 0.5 centimeters, PR is 14, and the altitude drawn to QR, so altitude would mean the perpendicular. So when I drop the perpendicular like this, let's say it is PS perpendicular, so this PS length is 6 centimeters. What is the length of the circumradius of the triangle PQR? Now by the way, what do we mean by circumradius, right? What do we mean by altitude? What are the properties associated with them? I hope we are clear with. I, however, here in this particular session would be briefly covering them. Now when I talk about the altitude, altitude is nothing but the height of the triangle, right? Height of the triangle. So one thing that we need to know about the altitude is the area of a triangle is given as half base into the altitude, or which is in general called as the height of the triangle. So half base into height, when we say height, that height is nothing but your altitude. Right? Now one more thing that we need to understand about altitude is a particular case for isosceles triangle and equilateral triangles. So in case of isosceles triangle, where two sides are equal like this, these two sides are equal, from here if I drop an altitude, it will bisect the third side. So here this altitude will also be the median. So in case of isosceles triangle. Similarly in case of equilateral triangle, where all sides are equal, no matter where you drop the altitude, from here or from here or from here, no matter how we drop, which altitude we consider, each of the altitude will also be the median too. Okay. So that's in case of equilateral triangle, this is in case of isosceles triangle. Okay. So these are some properties associated. However, none of these would be applicable here. I am not saying that because I don't know if this is isosceles triangle, definitely it is not equilateral. So maybe QR could be equal to 19.5, I don't know. So then it might turn out to be isosceles, but this is a particular case that we have properties of altitude in case of isosceles and equilateral. One more point is, what do we mean by circumradius? Now circumradius basically means it is a radius of a circle. Now what type of circle? This is radius of the circumcircle. Now what do we mean by circumcircle is, I will just clean all of it, alright, you may note it down. So if I take a triangle like PQR, and let us consider a point which is at equal distance from the vertices P, Q and R. So let us say the point is something like this. So this is a point which is equidistant from P also, Q also, R also. So that means with this point as the center and radius as one of these distances, if I draw a circle, I will get a circle like this which passes through the three vertices. This is called as a circumcircle. And the radius of the circumcircle is called as a circumradius, which we represent by capital R. So this will be generally represented as capital R, the radius, circumradius. There is one more type of radius. So to differentiate between the two types, we write this as capital R, the other one is written as small r, in radius, that is in radius. However, for today's class, for this particular question, circumradius is being asked. Okay. So these are some properties that we need to know about the circumradius and the altitude before we proceed with the discussion here. So now there are some formulae that we have for the areas of triangles. So one of the formula is half base into height, as we discussed. Here the question is asking you to find out the circumradius. There is one particular formula for area of triangle which involves the sides of the triangle. It goes like this. Observe, area of a triangle can be written as product of the three sides upon 4 times the circumradius, capital R is the circumradius. This is how you can find out the area also. This is also equal to what? Half base into the height, which is PS, because the height PS is known, so I will take the base as QR. Now on both sides we can see the term QR can be cancelled out, and now if you will see, you know PQ length, you know RP length for R will be equal to what? You know PS length, PS is 6. So when you simplify this, this will go 3 times and this 3 will go 6.5 times. So thus the value of R will end up being 6.5 into 14, so it will be 91, right? 91, 13 by 2, 13 into 7, 91 by 4. Okay. So the radius, I think is asking the circumradius only. So what is length of the circumradius? We can say that circumradius value will be 91 by 4, which is nothing but 22.75. The units are centimeters. So there is this formula that we have for area of triangle which involves the circumradius also. So this could be the learning that we have out of this particular question. So area can be written in terms of circumradius this way. Now there are some other formulae also. At this moment let me share few more formulae for area of triangles. Area of triangles can also be written as, area of triangle can also be written as in radius into semi perimeter. We can also write it like this. Area of triangle can also be written as root over S into S minus A into S minus B, where A, B and C are the side lengths, S is a semi perimeter. Area of the triangle, one of the most commonly used formula that we have, half into product of any two sides, half into product of two adjacent sides into sine of the included angle, half AB sine theta. So these are some formulae. Of course there is formula for area of equilateral triangle, area of isosceles triangle. There is also a formula which deals with in radius and circumradius, particularly for right angle triangles. Alright, let me just share that also. So area can also be written like this, small r into small r plus 2 capital R. So this formula is a special formula which works only for right angle triangles. Alright, so besides this there are few other formulae that we have for areas of triangles. I hope you are clear with this question. Okay, so this is how you can solve it. Alright, calculation wise we may check. There might be an error. I have tried to see, 1 second, let's do it again. 3 times 3 will go 6.5 times, R will be equal to 6.5 into 14, which is 91 by 4. Okay, I think it's okay. Alright, so I hope we are clear with this. Now this is one question that I had for you. Now there is another question which would be making use of another set of concepts. Please look at this. Again you can pause the video at this moment, give this question a try, and then you can just resume it, alright, and check your answer. I however will be discussing it right away, but before I discuss this, there is something related to this question that I want to share with you, which is the concept of similarity of triangles. So what do we mean by similar triangles? What happens in case of pair of similar triangles? What are the properties that they hold? Alright, what is the relation between areas, sides, etc. Alright, let's try to discuss that a little bit. So what do we mean by similarity? So similar triangles are basically two triangles which have the same shape but size is not necessarily same. Now such triangles are said to be similar. So basically two triangles which are appearing to be same, alright, but sizes are different. One is huge, other is really small. For example, you can consider the Indian map. map of India, right. So there could be two different Indian maps that we have, one which is a paper map, other could be a chart. Now both are similar because the ratio of the length, breadth, right, the ratio of the perimeters all would be same. They are similar diagrams, right. They are not identical diagrams. One more example you may take is, let's say there is an actual Ferrari car and there is a miniature version of that car, right. The two items would be said to be similar, not identical, right. So similarly, there will be similar triangles, not identical triangles. Now what do we mean by similarity? How do we prove it is? One of the ways of proving similarity is by AA property, AA rule. So what does this AA rule state is? This is angle, angle. AA means angle, angle. So what it states is, if two angles of one triangle, say this is 40 degree, this is 65 degree. Say if two angles of one triangle are equal to 40 degree, 65 degree. So these two angles as we see are equal to these two angles of separate triangle. If two angles are equal pairwise like this, the two triangles are said to be similar. This is the symbol for showing similarity. So one of the easiest ways to prove similarity between two triangles is simple, prove two angles are equal. Two angles of one triangle are equal to two angles of some other triangle. We can say that the two triangles will be similar. One more way to prove similarity is SSS similarity. It's side, side, side similarity, right. So this is SSS property. So what it states is, if you take two triangles ABC and PQR, and if you notice the ratio of the corresponding sides, meaning ratio of the side length of AB with PQ, BC with QR, and CA with RP, if this ratio turns out to be same, say equal to K, if the ratio of the sides is same, even then we will say the two triangles are similar. So one way to prove similarity is this, second way is this. Third way of proving similarity is something called as SAS property, SAS similarity, side angle side, side angle side is the full form. So what it means is, if you take two triangles like this again, ABC and PQR, so if you notice that the ratio of AB and PQ is same as AC and PR, so these two sides, pair of sides are having the same ratio, and the included angle, angle A, angle P, they are equal. Two sides have the same ratio and the included angle is equal, even then we will say the two triangles are similar. So these are the various ways, three different ways in which you can prove similarity. Quickly make a note of it, and now let's look at what is the utility out of similarity, what are the properties that we have out of similarity. So this is how you prove similarity. Now once similarity is proved, once it is proved, what do we get out of it? So what do we get out of it is, if two triangles are similar, say if I say triangle ABC is similar to triangle PQR, then point number one we can immediately conclude is ratio of the sides, corresponding sides, AB corresponding is PQ, order is very important, BC corresponding is QR, second and third here, AC corresponding is PR, first and third here, the ratio will all be same. And one more thing, extension point, not just the ratio of the sides, ratio of the medians also, ratio of the altitudes also, ratio of the perimeters also, ratio of circumcenters also, ratio circumradius also, ratio of in radius also, all these ratios are also going to be same. So for example, if this is say some value like 2 by 3, ratio of circumradius is also 2 by 3, ratio of perimeters is also 2 by 3, everywhere it will be same ratio. I am writing only side, but I am just saying it orally. This ratio will be true for all other dimensions, linear dimensions that the triangle has, median, angle bisector, altitude, radius, etc., all of that. Now one more thing, if ratio of sides is K, one more thing that we can say is ratio of areas, area of triangle ABC by area of triangle PQR. If the ratio of sides is K, ratio of areas will be K square. So for two similar triangles, if ratio of sides is K, ratio of areas will be K square. Okay. So now after this basic understanding of similarity, now let us enter the question. Let's solve it. Consider the triangles PQR. PQR is the triangle that we have, PQR, where S is a point on PQ such that QR is 20. So QR is given to be, it's written here 20. SQ is 16. RS is 8. And angle QRS is this angle, is QPR. So if this is theta, this is also theta. So let's do one thing. Consider, what is he asking us? What is the ratio of perimeters of the triangle PRQ to that of RSQ? PRQ the larger one, RSQ the smaller one. What is the ratio of perimeters? See, RSQ the perimeter is already known, isn't it? RSQ is nothing but 8, 16 and 20, which happens to be what? 24, 44. So this is RSQ is already 44, the value. We have to just find PRQ perimeter. So PRQ means the larger triangle's perimeter. How we can do it is, so basically we have to find the side length, right? PR and PS, my job is done. Let's use similarity here. Notice the following triangles, triangle PQR, okay, and consider the triangle, okay, PQR, and consider the triangle RSQ. Look at this. Look at these two triangles. Now in this triangle, what is angle P? It's theta. Now in this triangle, what is angle R? It's theta. Both are equal. In this, what is angle Q? It's this alpha. What is this angle? One second please. PQR, and here I will take R with P. RQS, order is very important, I said, RQS you take. Here Q is alpha, here also Q is alpha, is a common angle. So that means in these two triangles, we have just shown that two angles here are equal to corresponding two angles here. Hence, can I say the two triangles are similar? Now, if the two triangles are similar, ratio of the corresponding side should be same. Means what? PQ by RQ will be same as QR by QS will be same as PR by RS. Let's try to find it out. What is PQ? Let's put in the values. PQ we don't know. RQ is how much? RQ is 20. What is QR? How much is QR? QR is 20. What is QS? QS is 16. Okay. So when you solve this, you will get the value of PQ here. Notice. So when you solve this, what do we get? 4 goes 4 times, 4 goes 5 times, 4 goes 5 times. PQ will be equal to 5 into 5, 25. So this entire length is now known. It's 25. So that means we can also calculate PS if need be, because this length SQ is 16. So this will be the remaining. 25 minus 16 is 9. Not just that, look at this now. We want PR also. So for that I will use this PR by RS will be equal to QR by QS, which is 20 by 16. And how much is RS? RS is 8. PR by 8 will be equal to 20 by 16. So 16, 8 will go 2 times, PR will be 10. So this is 10. Now once you get this, what is perimeter of the larger triangle? It's 10 and 25, 35, 35 and 20, 55. So thus, the perimeter of this triangle PRQ is 55 and that of RSQ was 44. Required ratio is 55 by 44, which is nothing but when you cancel out 11, 5 by 4. So thus in that missing box, what should come? 5 should come there. Right? I hope we are clear with this, the concept of similarity and associated problem. Right? So please copy this. Let me just clean this all. Now there is one more question that we have, alright, based on the same similarity. Alright, let's take this up. Again, pause the screen, try this out. We'll anyways discuss the question here. So it says in a triangle ABC, 3 points DEF are chosen on sides BC, AB and AC respectively. I'll just draw it once. So triangle ABC, points DEF are chosen on sides something like this, right? Such that, what does this say? DE is parallel to AC. So DE is parallel to AC. So sorry. So I think we have taken it in the wrong way. One second. I'll just redraw it again. This is your ABC triangle, right, the larger one. This is your point D, this is E, and this is F. F is on AC, I believe. F is on AC, E is on AB, alright. So it's like this. Says that DE is parallel to AC. So when I connect D with E, so this segment is parallel to AC. And DF is parallel to AB. So DF, like this, is parallel to this side, AB. If the area of the triangle BDE, BDE is this small one, is 36, so this area is 36 square units, and that of the quadrilateral AEDF, AEDF is this quadrilateral here, so this area is 60. Find the ratio of the perimeter of the triangle CDF, CDF is this, and that of triangle ABC. So smaller triangle and the larger triangle, what is the ratio of perimeters? Okay. So how do we go about it? Let's try to understand. Notice please observe. Can we say if you consider the triangle BDE and consider BCA. So triangle BDE and BCA. Look at this two. So can I say in these two triangles B is the common angle? I hope you can see that for smaller and larger both angle B is same. Next notice, since AC is parallel to ED and BC is the transversal, so can I say this angle here will be same as this angle here, corresponding angles. So parallel lines cut by a transversal, corresponding angles are equal, so these two shall be equal. So that means angle D here will be equal to angle C here. So now we have proved that two angles here are equal to two angles here, the triangles will be similar, we can say. Similarly we can show that triangle CDF and triangle CBA, now these two can also be similar, shown to be similar. How? This is a common angle, and again similarly angle D and angle B will be corresponding angles because DF is also parallel to AB, DF is also parallel to AB, that is why. So these two are pair of similar triangles, these two are also pair of similar triangles, right. So if the triangles are similar, we have a property that ratio of corresponding sides will be equal, right, ratio of corresponding sides will be equal. So what will be the ratio of sides here? Let's try to understand. So before we do any of that, let us try to assume that this area out here, this area of triangle CDF is x square units, let's assume that. So what will be the ratio of areas of these two triangles BDE and ABC? So ratio of areas triangle BCA will be equal to what? This is 36 by this is 96 plus x. Okay. Similarly here, what will be area of triangle CDAF CBA? It is going to be x by same 96 plus x, 96 plus x. Okay. Next thing that we may notice out here is, one more thing that we can notice out here is, observe please, if triangle BDE is similar to triangle BCA, can we not say the ratio of BD by BC will be same as, will be equal to square root of this, because we just now saw that if ratio of sides is k, ratio of areas will be k square. Now we know ratio of areas, so ratio of sides will be square root of this. See, one hunch that I am getting here is the value of x should be 25, because 96 plus 25 gives me 121, which is also a perfect square. But let's try to prove that right. So BD by BC, we get it as this, right. Now similarly here, can we say CD by CB will be square root of this, 6. Now what is CD? So let's try to write it this way. Please notice, if I now try to add these two, because denominator BC is same, so if I try to add these two, BD plus CD is nothing but BC, denominator same BC will be equal to Root 96 plus x is common, that is same. So numerators can be simply added, root x plus root 36, which is nothing but 6. So this is 1. So when you simplify this, root 96 plus x will be equal to root x plus 6. How do we solve for this? Either you square it, or even now you can observe, see that x equal to 25 will satisfy. If you put x equal to 25, this is root 121, 11. This is root 25, 5 plus 6, 11, matches. Hence we may say the value of x is going to be 25. So this area we may write instead of x as 25. So the moment this is 25 square units, what is he asking us? What's the ratio of perimeter of triangle CDF? This to that of ABC. So I just now said, in case of similar triangles, ratio of sides is also equal to ratio of perimeters. So what was the ratio of sides? It was this. So thus can I say ratio of perimeters will also be this, which is root of x is 25 by 96 plus 25 is 121. So this is nothing but 5 upon 11. So the answer should be 5 upon 11. I already have a 5 there. So in denominator we will simply place a 11. That should be the answer. Okay. So similar triangles, we could do it like this. You can copy this. Now let me just clean this all. So with this we have come to the end of today's session. Right? So what we will do is in the subsequent sessions we will discuss more of the concepts from geometry, from various other areas also, circles, polygons, quadrilaterals too. But for today's class that is the end of it. Right? So before I end the session here, I would suggest all of you to hit the subscribe button, because we keep on uploading such content regularly, right, which I feel would be really helpful towards your CAT and other examination preparation. Right. On that note, let me end the session here. Thank you and all the very best.